Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the construction of the paper tray and we are required to obtain the development of the lateral surface of this paper tray over here. Now here we can see in this paper tray we have got a rectangular base which is going to measure 50 millimeter by 60 millimeter. So the width of this paper tray happens to be 50 millimeter while the depth of this paper tray happens to be 60 millimeter. Now there are four walls of this paper tray which happen to be inclined in nature over here. While the wall onto the left side of this paper tray, it is inclined at an angle of 45 degree, and the right hand side surface of this paper tray, it is inclined at an angle of 60 degree with respect to the horizontal plane. So we can see that the two edges as they are visible to us in the front view projections over here, so they are not equal to each other. That is, on one side we are going to get lesser height of this wall over here from the horizontal plane, whereas on the other side of this paper tray the height of this edge or the wall of this paper tray, it will be higher than the height of the edge which is lying onto the left hand side surface over here. So now we have been provided with the constructional details, that is the front view projections of this paper tray, they are available with us. Similarly, the top view projections of this paper tray, they are available with us. So using the information available with us through the orthographic front view and the top view projections of this paper tray, we are required to evaluate the development of the lateral surface of this paper tray. Now let us proceed to evaluate the development of the surfaces of the paper tray. Now we can see that from the top view construction, so here the dimensions of the different edges of this paper tray, they are available with us into the top view projections over here. Similarly, we have been provided with orthographic projections of the paper tray in the front view projections over here as well. Now let us label different surfaces of this paper tray. Now as we can see over here, we have drawn the projector lines from the elevation projection view corresponding to the different edges onto the top view projections over here, so that we can establish the relationship between different points which are appearing into the front view projections and into the top view projections over here. So now we can see corresponding to the base of the paper tray. So here we have got the base of the paper tray. A, B, C, D happens to be the base of the paper tray which is resting onto the ground onto the horizontal plane over here. So here the front view projections corresponding to the points B and A of the base onto the front view projections. So they will be appearing as B dash and A dash. Similarly, corresponding to the points C and D of the base of this paper tray, we have got the front view elevation projections represented as C dash and D dash onto the XY reference line. Now corresponding to the four corners which are corresponding to the top surface of this paper tray, so 4 points we have marked over here as E, F, G and H over here. So we can see that the edges A, E and B, F, so they are inclined with respect to horizontal plane at an angle of 45 degree over here. So this edge length, it will be appearing as a shorter edge length over here. Similarly, the edges DH and CG, they are inclined at an angle of 60 degree. So we have obtained the larger edge length corresponding to the apparent length of these edges into the front view projections. Now we can check corresponding to the top points of this paper tray F and E over here. So these 2 points F and E, they have been projected as F dash and E dash into the front view projections over here. Similarly, the corner points G and H, they have been projected as G dash and H dash into the front view projections over here. So now we can check that these two edges AE and BF, so they happen to be inclined with respect to the vertical plane. Similarly, the corresponding front view projections, they will be A dash E dash and B dash F dash over here. So again, these two edges over here of the paper tray, they are also inclined with respect to the horizontal plane. So we do not have the true length projections corresponding to these two edges, that is AE and BF, either in the front view projections or in the top view projections over here. Similarly, corresponding to the edges DH and CG, we can see in the top view projections, these two edges again, they happen to be inclined with respect to the vertical plane. And similarly, in the front view projections, D dash, H dash and C dash, G dash projections over here, so they are also inclined with respect to the horizontal plane. So we are not able to observe true lengths of these two edges DH and CG either in the front view projections or in the top view projections over here. So now, in order to obtain the development of the paper tray, we need to obtain the true length of all of these four edges, that is A, E, B, F, C, G and DH over here. So let us now obtain the true length of the inclined edges of this paper tray such that we need to obtain the development of the lateral surfaces of this paper tray. So now, using the principles of rotation of the line method, now here we have got two edges. Which are these two edges in the front view? A dash E dash and B dash F dash over here. Now these two edges, they happen to be inclined with respect to horizontal plane in the front view projections. So now with A dash B dash as the needle point, we are going to open the compass is equal to the radius A dash E dash or B dash F dash over here. And now once we rotate the points E dash and F dash in such a way that now this apparent length, that is A dash E1 dash and B dash F1 dash, they should become parallel to the horizontal plane over here. Now since apparent lengths in the new orientation, that is A dash E1 dash and B dash F1 dash, now they happen to be parallel to the horizontal plane. So now the projections of these 2 points E1 dash and F1 dash into the top view projections over here, they are going to provide us with the true length of the edges AE1 and BF1 over here. So how we have been able to obtain the true lengths over here? From the points E1 dash and F1 dash, we have drawn perpendicular projectors onto the locus lines corresponding to the points E and F over here. So wherever this vertical projector through E1 dash, it is going to intersect with the horizontal locus line drawn through the point E. So we have obtained the point E1 over here, and once we join the points A and E1, now the true length of this edge AE has been obtained as AE1 over here. Similarly, we have drawn the vertical projector from the point F1 dash of the elevation. Now once this vertical projector drawn through the point F1 dash, it intersects with the horizontal projector drawn through the point F over here. So this point of intersection, it will provide us with the location of the point F1 in the top view projection over here. Now once we join the points B and F1, so we have been able to obtain the true length of the edge BF into the top view projections as BF1 over here. Now we can check the edges AE1 and BF1 happen to be the true length. So whatever true length of AE1 we have evaluated, now once we transfer this point onto the other projection line that is corresponding to this face over here. Now this point E1 we can project over here, so that now we will be able to obtain the edge AE1 in the other orientation also. That is, this is the location of point E1 corresponding to the vertical orientation. Now we have transferred this into the horizontal orientation over here, so that the second face we should be able to evaluate over here. So now this point E1 from the vertical orientation has been shifted or transferred into the horizontal orientation, so that this face true shape we should be able to obtain over here. And these two edges, they should be having the same edge length over here. Similarly, corresponding to this edge BF1, now we can check this orientation we have obtained corresponding to this surface of the paper tray over here. So this surface happens to be B, A, E and F over here. So corresponding to this surface, now we can see this is true length, this is also true length, this is also true length, and this is also true length. And now this point F1 from the vertical orientation, we need to shift this point F1 into the horizontal orientation, so that once we join the points BF1 over here, so from the vertical orientation we have been able to shift this point into the horizontal orientation, so that the true shape of this inclined flap or the surface of the paper tray we should be able to evaluate over here. Now we have been able to obtain the true lengths corresponding to the edges AE and BF. Now let us evaluate the true length of the edges DH and the edge CG over here. Now we have seen that the edges DH and CG in the top view and D dash, H dash and C dash, G dash in the front view, they are all inclined with respect to vertical plane and horizontal plane respectively. So we have got the apparent length projections corresponding to these two edges in the top view and the front view projections over here. So now using the principles of rotation of the line once again, with C dash D dash as the needle point of the compass, we are going to open compass is equal to the radius D dash H dash or C dash G dash over here. Now once we rotate this edge length in the front view projection, that is the apparent length in the front view projections over here with respect to the point C dash D dash, so that in the new orientation the apparent length, that is D dash H1 dash and C dash G1 dash, they should become parallel to the horizontal plane. So onto the horizontal plane, into the top view projections, we will be able to obtain the points H1 and G1 over here. So now we can see how we have obtained this point H1. From point H1 dash, we have drawn a perpendicular projector into the plan projection view, and wherever this vertical projector from H1 dash, it is going to intersect with horizontal projector drawn through the point H. So this intersection point has provided us with the location of the point H1. And once we join DH1 over here, so this is the true length of the edge DH obtained into the vertical orientation. Similarly, once we draw perpendicular projector from the point G1 dash of the elevation projection view, now this vertical projector drawn through the point G1 dash, wherever it intersects with the horizontal projector drawn through the point G. So now this point G1 has been obtained over here. Now once we join CG1 over here, so we have been able to obtain the true length of the edge CG as CG1. So this is the true length which is obtained into the vertical orientation. Let us now transfer this distance into the horizontal orientation over there, so that the true shape of this inclined surface of the paper tray can also be evaluated. So now we have transferred this point H1 from the vertical orientation into the horizontal orientation, and once we join DH1 over here, so the same true length we have been able to transfer into the horizontal orientation. Similarly, from point G1, once again, this is true length which is available with us in the vertical orientation. Now if we transfer it over here and join C and G1 points over here, so now corresponding to this surface, that is BCGF, now the true shape of the edge CG has been obtained into the horizontal orientation. And now we can join the points E1 H1 over here, we can join the points E1 F1 over here, we can join the points F1 G1 over here, and we can join the points H1 G1 over here. And now we can see we have been able to obtain the true shape of the surface ADHE over here. So this is the apparent shape of the surface ADHE, whereas corresponding to this inclined surface of the paper tray, now the true shape happens to be ADH1 and E1 over here, right? So this is true shape of surface number 1 over here. Now let us obtain true shape of surface number 2 or flap number 2. So flap number 2 is this one, A, B, F and E over here. This is the second inclined surface of the paper tray, ABFE, and this happens to be the apparent shape. Now the true shape of the surface ABFE happens to be ABF1 and E1 over here. So this way, now the true shape of surface number 2 or flap number 2 of the paper tray has been obtained as ABF1 E1 over here. Now the third surface, this is the third surface. So third surface happens to be B, C, G and F over here. So this was the apparent shape projections of the surface A, B, G, F in the top view projection. Now the true shape projections corresponding to this surface will be B, C, G1 and F1 over here. So the true shape of the third flap or the third inclined surface of this paper tray has been obtained over here as B, C, G1, F1 over here. And this is the last surface. Now which is this surface? This surface happens to be C, D, H and G over here. So this is again the apparent shape projection corresponding to the surface CDHG. Now what are the true shape projections? So the true shape projections of surface number 4 or the flap number 4 happen to be C, D, H1 and G1 over here. So this way the true shape of all the 4 inclined surfaces of the paper tray, they have been obtained. So this is our surface 1, this is the surface 2, this is surface 3 and this is surface 4. While we had already obtained the true shape of the base of this paper tray as ABCD. Why? Because this base of the paper tray happened to be resting onto the ground on the horizontal plane. So the true shape was already visible to us in the top view projections over here. So the 5 surfaces of the paper tray were there, out of which the base true shape we had already obtained 50 millimeter by 60 millimeter. So here we had got BC and AD edges as 50 millimeter and AB and CD edges, they were represented as true length projections over here as 60 millimeter. So now with this discussion we can see that we have been able to obtain the true shape projections corresponding to all the 5 surfaces of this paper tray. The base of the paper tray, surface 1, surface 2, inclined surface 1, inclined surface 2, inclined surface 3 and the inclined surface 4 over here. So this way we have been able to obtain the development of all the lateral surfaces of the paper tray as it has been discussed over here. This is all for today. So we are going to continue with further discussion regarding few more illustrative cases of development of the surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.